So in this session we can discuss about the Colpitts oscillator. So last video we can discuss about the Hartley. So what is the difference between Hartley and Colpitts means we have a L1 and L2 in Hartley and 1C. So here two capacitor and one inductor. So this is the two difference. So it is a LC oscillator which use two capacitor and one inductor in its feedback network. So as earlier stated, so this is the first stage is amplifier stage and second is the feedback network. So here we can again this is also having a output of V0 is 180 degree. So after this signal is which is given to us the feedback network. So VF we have a 360 degree phase shift. So again it will satisfy the oscillator condition. So then we can produce the conditions for oscillation. So the amplifier stage uses an active device as a transistor in CE configuration. So here we can use CE configuration and resistor R1, R2, RC provides the proper DC bias to the transistor. So the feedback network consists of two capacitor that is C1 and C2 and one inductor L. So which determines the frequency of oscillation. So next we go for operation. So when the supply voltage VCC is given to the circuit, transient current is produced in the tank circuit. So what is meant by tank circuit? So we have a inductor and capacitor, so which act as a storage. So we can use in our home the tank for a storage purpose. For that only we can set it as LC circuit, is otherwise known as tank circuit. The oscillator current in the circuit produces AC voltage across C1 and C2. The feedback network, the terminal 3 is grounded with the 0 potential. So this is the terminal 1 and 2 and here we have a 3. So and then there's the phase difference between the terminals 1 and 2 is always 180 degree. So in CE mode the transistor provides the phase difference of 180 degree between the input and output. Thus the total phase shift is 360 degree. So if the feedback is adjusted to get 360 degree, that is A beta which is equal to 1, that is gain, and feedback factor beta which is equal to 1, the circuit can act as a oscillator. And then equivalent circuit for the Colpitts circuit. So here we can see L and here C2 and C1 HIE. So this is IB and here we have a, so this is output and this is emitter terminal, base and collector. So this is the equivalent circuit of the LC oscillators in Colpitts. So the frequency of oscillation, the general expression for the oscillator is HIE Z1 plus Z2 plus Z3 plus Z1 Z2 into 1 plus HFE plus Z1 Z3 which is equal to 0. This is equation number 1. So for Colpitts oscillator we want to determine the value of Z1, Z2 and Z3. So we have a C1 and C2. So we have a inductive capacitance is Z1 which is equal to 1 divided by J omega C1, Z2 which is equal to 1 divided by J omega C2, Z3 which is J omega L. We can substitute these Z1, Z2, Z3 value in above equation 1. So therefore HIE which is equal to 1 divided by J omega C1 plus 1 divided by J omega C2 plus 1 J omega L plus 1 divided by J omega C1, 1 divided by J omega C2 into 1 plus HFE plus third term 1 divided by J omega C1 J omega L which is equal to 0. So from this we can calculate HIE into minus J divided by omega C1 and minus J divided by omega C2 plus J omega L. So plus 1 divided by J square omega square C1 C2 into 1 plus HFE plus L divided by C1 which is equal to 0. So we can take as J minus J term as a common out. So J minus J HIE into 1 divided by J omega C1 plus 1 divided by J omega C2 minus omega L into minus 1 plus HFE divided by omega square C1 C2 plus L1 divided by C1 which is equal to L divided by C which is equal to 0. So L1 divided by C1 minus 1 plus HFE divided by omega square L C1 C2 minus J into HIE into 1 divided by omega C1 plus 1 divided by omega C2 minus omega L which is equal to 0. So at resonant condition the imaginary part is equal to 0. So minus HIE into 1 divided by omega C1 plus 1 divided by omega C2 minus omega L, so which is equal to 0. 1 divided by omega C1 plus 1 divided by omega C2 minus omega L which is equal to 0. So we can keep it as omega L in the opposite side, omega L which is equal to 1 divided by omega C1 plus 1 divided by omega C2 which is equal to 1 divided by omega. So into, so we can take it as a omega is common outside, so 1 divided by omega into 1 divided by C1 plus 1 divided by C2. So here omega square which is equal to 1 divided by L into 1 divided by C1 plus 1 divided by C2. So we can calculate from this, we can omega square which is equal to 1 divided by L. So this C1 and C2 which is equal to C equivalent. So that is 1 divided by C equivalent which is equal to 1 divided by C1 plus 1 divided by C2. So omega which is equal to 1 divided by L into C equivalent. So we know omega is equal to 2 pi f. So f is equal to 1 divided by 2 pi square root of L into C equivalent. So next we can calculate the condition for oscillation. So in order to determine the condition for oscillation, the real part of equation is equal to 0. So L divided by C1 minus 1 plus HFE divided by omega square C1 C2 is equal to 0. So L divided by C1 which is equal to 1 plus HFE divided by omega square C1 C2. So substitute the equation in 3. So we can cancel this L and this L. So and then here we can calculate 1 divided by C1 which is equal to 1 plus HFE into C1 plus C2 divided by C1 C2 into C1 C2. So here we can take it as a LCM, C1 and C2 as a LCM. So this C1 C2 are cancelled and then we can calculate C1 plus C2 divided by C1 which is equal to 1 plus HFE. So here we can calculate HFE is equal to C2 divided by C1. So this is the forward gain of the transistor.